Hello everybody. Let's quickly discuss some questions related to arithmetic mean, okay? And the questions will also be more mathematical than calculative, okay? I assume that you've already taken up courses which deal with the calculative questions, okay? All right. Calculate the arithmetic mean of first and positive integers. So we're given the integers 1, 2, all the way up to n, and we need to find its what do you call it arithmetic mean. So its arithmetic mean is equal to, there are n different observations, so 1 over n times the sum of these numbers, 1 plus 2 plus all the way up to n. Okay, now what we can see is that this is a it has a well-known formula. Okay, the sum of first n natural numbers is, we put 1 by n as it is first. This sum is equal to n times n plus 1 over 2, which gives, after this cancellation, n plus 1 over 2 is the required arithmetic mean of these numbers. Okay, now what if we have calculate the arithmetic mean of cubes of first and positive integers? Then we need to find the arithmetic mean of these observations. Okay, so this will be something like this. All right, now we know the sum of cubes of first n natural numbers is n squared n plus 1 squared over 4. Okay, this is a well-known formula from intermediate algebra. So this will simplify to n plus 1 squared over 4. Okay, this is the arithmetic mean of these observations. Now what if we have the arithmetic mean of squares of first and positive integers? Then in that case we need to find this arithmetic mean of these observations, which would mean something like this. Okay, and we know that this sum is equal to n times n plus 1 times twice n plus 1 all over 6. You can cancel n with this n to get n plus 1 multiplied by twice n plus 1 over 6 is the required arithmetic mean. Okay, now let me quickly copy another question I want to discuss. Okay, all right, this is the question I want to discuss now. What we're given is that the arithmetic mean of n observations is x bar. The sum of first n minus 1 observations is k. Then under this condition, we need to show that the nth term is nx bar minus k. Okay, so this was a question of Tribhuvan University BSc first year of the year, I don't remember. Yeah, 2070 means approximately 2014. Okay, 2014. Okay, 2013 or 2014. Okay, 2070 BS. And this is the actual exam date. Alright, whatever. It's not so much of a concern. Okay, first of all, let's assume something. Let x1, x2, all the way up to xn be the given observations. Alright. Then we're given that x bar, then what we have is x bar is equal to 1 over n times summation 1 to n xi. Okay, first equation. And we're also given that the sum of first n minus 1 observations is k. So first n minus 1 observations is equal to k. This is also something that we are given. So these two things are what we are given. Then we need to show that xn, okay, what we need to show is that xn is equal to nx bar minus k. Okay, xn is equal to nx bar minus k. Now you can take the value of nx bar from this expression, from this equality or equation, put it here. You can take this value of k from here and substitute it right here, simplify it and get xn. Okay, you can do it like that also, but I'm going to do it in a little different way. Let's see. What we have is x bar, nx bar is equal to nx bar is equal to the sum I equals 1 to n, what do you call it, xi, which is equal to, the sum is equal to x1 plus x2 plus all the way up to xn minus 1 plus xn, right? Yeah. And we have the value of this sum to be k from equation 2. So this is equal to k plus xn. Okay. Now, taking this k to this side, we will get xn on the right hand side and nx bar minus k on the left hand side, and we just interchanged the LHS and RHS. Okay, and this is what we were supposed to prove. Okay, so this is how we do it. All right. Okay, let's look at another question. All right, this is another question I want to discuss. Okay, it's a very simple question. We need to find the arithmetic mean of this observation. Okay, and since r is not equal to 0 and not equal to plus or minus 1, this is a geometric sequence, finite geometric sequence. Okay, and we can write a plus ar plus all the way up to ar n minus 1 to be equal to a times the common ratio rn minus 1 over r minus 1, first term common ratio. Okay, so we just need to use this formula. So the mean will be 1 over n a plus ar plus ar n minus 1, okay, which is equal to 1 by n times ar n minus 1 over r minus 1. So simplifying it, we can write it ar n minus 1, okay, ar n minus 1 over n times r minus 1. And if you want, you can use the formula for rn minus 1 to cancel r minus 1 with another r minus 1 in the numerator and get some kind of a polynomial expression, but that's not necessary. This is all right. Okay, all right. Let's look at another question now. Okay, here's another question. Okay, this was is this an exam question? Yeah, this is the proposed model question for the course that we had in 2017. Okay, the year I joined, a year before I joined BSc. Okay, it's around 2013 or 14. Okay, I was in class 12, by the way, during this time. All right. Yeah, what we are given is n is a positive integer, no doubt, and we're given observations like x1, x2, all the way up to x3. Okay, we need x3, x3, all the way up to xn plus 2. Okay, xn plus 2, xn plus 1, xn plus 2. Okay, x1 gives the mean of these observations. Okay, x1 gives the mean of these observations. x2 gives the mean of these observations. And x3 gives the mean of these observations. Like this. And we just need to prove these two relations. Okay? Now the way is really simple. Then we can take x2, do some algebraic manipulations here and there, and obtain this from x2, but I'm not going to do that. I'm just going to simplify the right hand side and obtain x2 bar. Okay, is that okay to you? I hope it is. You can try the other way around too. It doesn't matter. I'm just too lazy to do that. Alright, for the first relation, we have x1 bar plus 1 over n, xn plus 1 minus x1. Okay, x1 bar is equal to 1 over n, and the sum of the observations from x1 to xn, which means x1 plus x2 plus all the way up to xn, okay, plus 1 over n xn plus 1 minus x1 as it is. Alright, xn plus 1 minus x1. 1 by n is a common factor on both of these sides. Okay, so 1 over n, x1 plus x2 plus xn plus xn plus 1 minus x1. Alright, we can cancel out these x1 and x1 so that we get this sum, which is equal to 1 over n summation I equals to 2 to n plus 1 xi, which is nothing but x2 as per our given conditions. Now please wait for a second. Alright, this identity now, okay, just plug in the value of x2. What are we going to get? 1 by n, sum of the observations from x2 to xn plus 1, x2 plus x3 plus xn plus 1. Okay, this remains as it is, 1 by n, xn plus 2 minus x2. Okay, we have 1 over n as a common factor, so we take it out and get x2 plus x3 plus xn plus 1 on this side. From this side we have xn plus 2 minus x2. Okay, cancel out x2 with x2, x2 with x2, and so we obtain 1 over n, the sum of terms from x3 to n plus 2, x3 to n plus 2, xn plus 2. Okay, now this is equal to x3. Okay, this is equal to x3, just like in the first identity, just like for the proof of this identity. Okay, alright, that's how you do it. And I guess we can express x3 in terms of x1 as well by taking x2 equal to this thing over here, which means we can also write x3 bar is equal to x1 bar plus 1 over n is a common factor in both of these terms. So the sum of last two terms, okay, sum of last two terms minus the first term and the second term, like this. Okay, this is how we can express x3 bar in terms of x1 bar. Just substitute this value here. All right. Okay, now let's look at one more question. We're going to discuss two more questions now. All right, here's another very short question. Okay, this is a really short question. I should have discussed this before the previous question. Okay, anyways, this is a geometric sequence. Find a geometric sequence whose first term is 1, second term is, the common ratio is 2, and the number of terms are, there are n terms here together with 1, so the total number of terms are n plus 1. So we get 1 plus 2 plus 4 plus 8 plus all the way up to 2 to the power n, as a means 1, so yeah, 1 times 2 to the power n plus 1 minus 1 all over 2 minus 1. Okay, all over 2 minus 1, which is nothing but 2n plus 1 minus 1. All right, yeah, so the required mean is equal to 1 over n plus 1 times the sum, which is equal to, therefore, n plus 1, 2, n plus 1 minus 1. Okay, that's all about it. Now let's discuss a final question. Okay, let's discuss a final question. All right, here's a very short question again, and this is what do you call it, the converse of one of the questions, one of the properties of arithmetic mean. Okay, one of the properties. So we've shown that if a is equal to x bar, then summation I equals to 1 to n xi minus a is equal to summation I runs from 1 to n xi minus x bar is equal to 0. Okay, we've shown this part in the properties. Now we're going to show the converse part, this part. Okay, the opposite part of the property we've proved in a previous video. Okay, now for this, what are we going to do? Yeah, it's very simple. We're given this, so since we have summation I equals to 1 to n xi minus a is equal to 0, okay, we will get from the linearity property of the sum xi minus a is a constant, so I equals to 1 to n 1 equal to 0. This means summation I equals to 1 to n xi minus na is equal to 0. We take na to this side and divide both sides by n to get a is equal to 1 over n summation I equals to 1 to n xi, which means a is equal to x bar, which is what we were supposed to prove. Okay, all right, I guess that's all for today. Okay, thank you very much.